Hello and welcome to this video where I'll explain exactly how to solve any ODE of this form with one sort of stipulation there. This video is only going to focus on when this ODE is equal to a polynomial, but we'll get into exactly what that means later, and I'll have many videos in the future explaining what to do if this kind of ODE is equal to an exponential or a sinusoidal function. But before all that, if you just want to skip to any practice problem in this video, I'll have all of those timestamps in the description. So if you're still here, then you must be interested in the actual method of undetermined coefficients and learning what it is. So that's exactly what I'm going to tell you right now. So first of all, this is the kind of ODE that we're working with here. And so if you notice, this is the exact same form of ODE as a constant coefficient, linear second order, homogeneous ODE, except now it's not equal to 0, right? Now it's equal to a function g of x. And so that being equal to g of x turns this into a non-homogeneous ODE as opposed to homogeneous ODE. And that makes our life quite a bit more difficult. But they're still possible, but these ODEs do take a little bit of time and there's some room for error. So I implore you to, as you go along with this video, to maybe watch one or two examples first and then try the third one on your own, just so you get a feel for what it's like to actually solve one of these from beginning to end. And so let's just move forward with what the actual method of undetermined coefficients is. All right, let's go ahead and get into the actual method of undetermined coefficients. So step one, you start off by finding the homogeneous solution to your current ODE. And what that means is you solve your same ODE, but you pretend that g of x equals 0. So as you can see here, typically if this was a non-homogeneous ODE, this would equal g of x, but right now we're pretending it equals 0, and we solve that ODE. And that's actually going to be part of our entire non-homogeneous solution. And so we're going to get an answer, and that's going to be denoted as yh of x, and that's going to be half of our answer. And so steps 2 and 3 show us how to get the other half of our answer. And then step 4 is just going to be combining them. So let's move on into step 2. Step 2 is going to be kind of the meat of the undetermined coefficients actual method. And so step 2 is going to be different depending on what g of x looks like. So what's common across every kind of g of x is you want to write down the expected form of the inhomogeneous solution. But that expected form that you write is going to be different based off of the g of x that we're working with here. And so in today's video, we're going to be focusing on when g of x is an nth degree polynomial. But this is just a little key here to show you what your expected solution should look like based off of what your g of x looks like. So I'll go through a little bit about what this means. And even though I'm going to be focusing only on the nth degree polynomial version in this video, the next video will be when it's an exponential, and then the one after that will be when it's cosine or sine. So look out for those if they're out. All right, but g of x is an nth degree polynomial. So there's a couple of things to realize here. So an nth degree polynomial is just any polynomial of any order. So for example, g of x equals bx plus 1 is an nth degree polynomial, and in this case this is a first degree polynomial because we have a first power here. And so if you had this g of x, then you would guess that yn of x, and yn of x stands for the non-homogeneous part of the solution. You would guess that this is, let's say, a different constant than b. You'd say this is ax plus c. And so the only thing that you maintain throughout your guess and g of x is the nth degree of the polynomial. You'll never have an actual number in front of any x. So we see b here, but we write a different constant. We see 1 here, but we write c, a different constant. And actually this method is called undetermined coefficients because step 3 is going to be finding the unknown coefficients that we have just written, a and c. The actual definition that I have written right here may be a little bit confusing, but this is just a fancy way of saying that you take the order of polynomial that g of x is, and then you create a polynomial of that order where every x has a decreasing order. And so you don't skip any orders, and I'll show you what that means. So let's say g of x were to equal 3x squared, just 3x squared. Well, the highest order here is 2, and we need one order below all of that until 0. So we would actually guess yn of x to be ax squared plus bx plus c. And so maybe you see what I mean there. You can't skip any orders in your polynomial that you guess. But we'll see what that looks like when we go into a couple examples. Okay, so once you've written down your expected form of the inhomogeneous solution, step 3 is going to be to substitute that solution into the original ODE and then solve for the constants. So you'll see what that looks like in a couple of examples. And then once you've done that, step 4 is to write your final solution. And in the case of an inhomogeneous ODE, your final solution, y of x, is going to be the sum of the homogeneous solution that you found all the way back here in step 1, and then the sum of what you just found out in step 2 and 3, the non-homogeneous solution. Okay, so let's go ahead and get into some examples. All right, let's go ahead and move forward with the first example. So here we have y double prime plus 4y prime plus 3y equals 2x squared minus 3x plus 1. So in the above definition, this is going to be g of x, and here we have a polynomial. So step 1, I'll do it in the order that I had listed above, is find the homogeneous solution. So the homogeneous version of this equation is just going to be y double prime plus 4y prime plus 3y equals 0. And now we just solve this like we would a regular homogeneous form of this equation. So the characteristic equation is going to be r squared plus 4r plus 3 equals 0. And here we just need to solve for r. So in this case, we can actually factor this, and it's going to be r plus 3 and r plus 1 equals 0. So r plus 3, r plus 1 equals 0, just like that. And those two numbers add to 4 and multiply to 3. So we know that we did that correctly. And this is going to give us a r1 of -3 and a r2 of -1. And so now we just need to basically write the homogeneous solution. So yh of x, and if you remember, this just follows a very specific formula. This is going to be c1 e to the r1x, so -3x, plus c2 e to the r2x, so in this case -1 times x, or just -x. All right, so that's step 1 down the hatch, and so we have the homogeneous part of this equation solved. All right, let's move on to step 2, which is really the undetermined coefficients method. So step 2, I'm going to call this, and we need the expected form. And so I'll denote this as yn of x to signify that this is going to inevitably be the solution of the non-homogeneous part of this ODE. And so if you remember, g of x is going to be 2x squared minus 3x plus 1, and so we need to guess a polynomial of that order, but without any of the information about constants. So we're going to write ax squared plus bx plus c to have the same order of g of x, but without any information about what those constants may be. Okay, so that means that yn of x is going to be ax squared plus bx plus c, just like that. Step 3 then is going to be substituting this guy into the original ODE. But to do that, we need to take a couple of derivatives, right? Because this is an ordinary differential equation, and this is in terms of y double prime and y prime. So if we want to plug our guess of y into the original ODE, then we're going to need to take the first and second derivative so we can plug it in. All right, but that's not so bad. So yn prime of x equals just the power rule 2ax plus b, and so then the second derivative here, also not so bad, just the power rule, 2a. Okay, so now we can actually substitute this into the original ODE. Since this is our expected form of the solution, we can plug it in directly for y. And so the original ODE, I'll write it again right here, y double prime plus 4y prime plus 3y equals 2x squared minus 3x plus 1, and that's just so we don't have to keep scrolling back up. But now we get to plug in what we have written for y. So y double prime we said was 2a, and this is going to be plus 4 times y prime. Well, we said y prime is 2ax plus b, and then plus 3 times y, and y is just the direct guessed solution, which is going to be right up here, ax squared plus bx plus c, just like that. And then this is still going to be equal to 2x squared minus 3x plus 1. All right, so to move forward, we're basically just going to distribute the 2, 4, and the 3. So the 2 is already just with a, but here we can have 8ax plus 4b, and we can say plus 3ax squared plus 3bx plus 3c, still equal to the same 2x squared minus 3x plus 1. Okay, so now what I like to do is group all of these terms on the left-hand side based off of their order of x. So for example, I'll write an x squared right here, and then I'll write every term that's being multiplied by an x squared on the left side. And here that's actually just 3a, and then plus x, every term with an x. Let's see, I see 8ax, so I'll write an 8a here, and then I also see a 3bx, so I'll write a 3b here as well. And then x to the 0, well, I'll just write a parentheses here anyway, just to group all of the constant terms that have no x. So this will be 2a plus 4b, and then plus 3c. And then that still equals 2x squared minus 3x plus 1. All right, so actually this one equation kind of gives us 3 others. So we know that the left and the right-hand side have to be equal, right? But because we grouped by the power of x, so x squared x and then x to the 0, or just 1, we know that 3a right here has to equal 2 from here, so that the x squared terms are equal, because we know that inevitably the left-hand side is equal to the right-hand side. So if we equate the 3a outside of what we created for x squared and set that equal to the 2 that we know it inevitably has to be, that'll give us an equation for a in this case. So we know that 3a has to equal 2. And then we can do the same thing for the x term. So here we know that 8a plus 3b has to equal negative 3 in order for these equations to be equal. So 8a plus 3b inevitably has to equal negative 3. And then finally, we can do the same thing right here with the 1. So this will give us 2a plus 4b plus 3c, which equals 1. And this is again just by matching the coefficients of the different orders of x. And so our first equation here basically just directly gives us a, which is really nice. So divide both sides by 3, and a is 2/3. Now we can plug that into the second equation here. And so I'll write a little arrow. So this is going to be 8 times what we just found, a to b, which is 2/3, plus 3b, which equals negative 3. Okay, so this is the same thing as saying 16 over 3 plus 3b equals negative 3. And so here we just need to solve for b. So first thing I'll do is divide everything by 3, so that the 3b and the negative 3 just turn into 1s, and maybe this will end up looking a little bit nicer. So 16 over 3 divided by 3 is just going to be 16 over 9, plus b equals negative 1. Okay, so then let's just subtract the 16 over 9 to the right side, and we're left with b equals negative 1 minus 16 over 9. And so to get this in a form where we can actually subtract this, I'll just rewrite the negative 1 as negative 9 over 9 minus 16 over 9. And so they have the same base. All right, so negative 9 minus 16, that's going to give us a negative 25 on top. And then this is still over 9. Okay, so we found b as well. And now all we need to do is solve for c, and we can do that with the third equation. So 2 times a we found to be 2/3. plus 4 times b, which we found to be negative 25 over 9, plus 3c, the last unknown coefficient, and that still equals 1. And so here we just have another algebraic equation to solve. All right, so this is the same thing as 4 over 3 minus 100 over 9 plus 3c equals 1. And now I'll write everything in terms of, everything besides the 3c term in terms of a denominator of 9. So that's going to give us 12 over 9, just rewriting 4/3, minus 100 over 9, still just over 9, plus 3c equals 9 over 9, like so. So 12 minus 100 is just going to be negative 88, so negative 88 over 9 plus 3c equals 9 over 9, which means 3c equals 9 plus 88, so 9 plus 88 is just going to be 97, and this is still over 9. And then we can divide both sides by 3, so c then equals 97 over 9 times 3, which is 27. Okay, so now we have a, b, and c, and so we can write out our non-homogeneous solution finally. So yn of x, if you remember, is ax squared plus bx plus c, but luckily we just found out what a, b, and c are. So our non-homogeneous solution is going to be 2/3 x squared, because we found a to be 2/3 right here, and then we just found b to be negative 25 over 9, negative 25 over 9x, and then we just found c to be 97 over 27. So 97 over 27, like this. And so that's it with step 3, but remember there's one final step, step 4, and this is basically just writing the final answer out. So y of x for the entire ODE equals the solution to the homogeneous part plus the solution to the non-homogeneous part. And so let's see, the homogeneous part is going to be all the way up here, and that is right here. Okay, so that's just going to be c1 e to the negative 3x plus c2 e to the negative x. All right, c1 e to the negative 3x plus c2 e to the negative x, and then we add our non-homogeneous solution, which we just found right here. So this is going to be plus 2/3 x squared minus 25 over 9x plus 97 over 27. And so this is going to be our final answer for y of x. And so that's going to do it for this example. And as you can see, this method isn't actually insanely difficult. There's just a lot of different steps, and there's tends to be a good amount of algebra involved, so there's a little bit of room for error. But as long as you're able to check your work as you go along and make sure that what you're doing makes sense, then you should be able to get to the final answer with not so much hassle. All right, let's go ahead and solve this example. So the first step is always find the solution to the homogeneous part. So in the case of this ODE, the homogeneous part is just y double prime minus 4y prime minus 12y equals 0. So just replacing this g of x with a 0 and then solving that ODE. So here we need to write the characteristic equation. So this gives us r squared minus 4r minus 12 equals 0. And now we just need to actually solve for r here. So let's see, is this factorable? Let's see, two numbers that add to -4 multiplied to -12. So yeah, it looks like -6 and 2 are going to do that. So r minus 6 and then r plus 2 equals 0. This gives us r1 equals 6 and r2 equals -2. And then from there we can basically just write out the homogeneous solution. So the homogeneous solution is then c1 e to the 6x plus c2 e to the -2x. Okay, so that's half of our solution. And so now we need to move on to step 2. So step 2 is always going to be writing the expected form of the solution. So in this case, g of x equals 2x cubed minus x plus 3. So we need to write a guess or the expected solution with that same order of 3. So it's going to be ax cubed, and even though g of x doesn't have an x squared term, our expected solution can't skip any orders. So this is still going to be plus bx squared, and then one order down from that plus cx, one order down from that plus d. So this is going to be our non-homogeneous expected form of the solution. And so step 3 is going to be basically finding what a, b, c, and d are. So first step, just like the previous problem, is to take the derivative of y of x, yn of x, twice, so that we can actually plug it back into the original equation because it includes derivatives of y. Okay, so yn prime of x, that's going to equal, just using the power rule here, this is only a polynomial, so 3ax squared plus 2bx plus c. All right, that's going to be the first derivative, and so we can also take a second derivative here because our original ODE includes a second derivative. So 6ax plus 2b plus 0. Okay, so we have y prime, and y double prime. And so now all that's left to do is plug this into the original ODE and then solve for a, b, c, and d. So I'll write the original ODE one more time so we don't have to keep looking up. Y double prime minus 4y prime minus 12y equals 2x cubed minus x plus 3. Okay, so now we just plug in what we just found into this equation. So this is going to take up quite a bit of room actually, so I'll start kind of over on the left hand side. So y double prime we just said was 6ax, move this a little bit, so 6ax plus 2b, like so. Then we have a minus 4 times y prime, which we said was 3ax squared plus 2bx plus c. And then we have a minus 12 multiplied by just y, which we said was ax cubed plus bx squared plus cx plus d, which is still equal to the original right-hand side of 2x cubed minus x plus 3. All right, so now we just distribute the 4 and the 12, and then we'll group by the power of x. So nothing changes with the 6ax plus 2b over here, but now we have a minus 12ax squared, a minus 8bx, and a minus 4c. Now let's distribute that 12, so we're left with minus 12ax cubed minus 12bx squared minus 12cx, and then minus 12d. Oops, wrote a b instead, minus 12d. Still equals that same 2x cubed minus x plus 3. Okay, so now I'm going to group everything by their power of x, and so I'll start with x cubed right here. So x cubed, let's see where we see an x cubed. On the left-hand side, I only see 1, and that's going to be negative 12a. So negative 12a goes here. Now we're going to add x squared, and let's see where we see an x squared. So I see one here, and I see one here. So that's going to give us a minus 12a minus 12b, just like that. Now we're going to group the x terms. So let's see, I see a 6ax, I see a minus 8bx, and I see a minus 12cx. All right, so now we're just left with the constant terms. So anything that doesn't have an x, well, we start with 2b, then I see a minus 4c, then I see a minus 12d, like that. And that is going to still equal 2x cubed minus x plus 3. Okay, so just like the previous question, remember that these two sides are equal, and so that means that whatever in front of the x cubed on the left side has to equal what's in front of the x cubed on the right side. And same thing for the x squared, and same thing for the x, and same thing for the constant term. And in this case, you'll see when we get there, but because there's no x squared on the right side, actually negative 12a minus 12b will equal 0. But let's start with our negative 12a. So negative 12a has to equal 2. So that's our first equation. Negative 12a equals 2. Our second equation, negative 12a minus 12b, so negative 12a minus 12b equals 0 because there's no x squared term on the right. Our third equation is going to come from the orders of 1. So we have 6a minus 8b minus 12c, which just equals a negative 1. And then finally, we're left with the constant terms, which is going to give us our fourth system, or our fourth equation in our system of equations. So 2b minus 4c minus 12d, which is going to equal 3. All right, so now our job is to solve this system of 4 equations for 4 unknowns. So let's start with the first equation, which just says negative 12a equals 2. So let's just divide both sides by negative 12, and we get a equals negative 2 over 12, or in other words, a equals negative 1/6. Okay, nice. So we got a pretty much immediately. Now we can plug a into our second equation and then solve for b. So negative 12, and then I'll retain the unsimplified version of a just because the 12s will cancel, but that's the same thing as negative 1/6, and then minus 12b equals 0. So the reason I did that is these 12s will cancel, and then we'll have a 2 minus 12b equals 0, which means that 12b equals just 2. So these negatives will cancel once we subtract 2 onto the other side, which means that b also equals a 1/6, except this time it's going to be positive. So a equals negative b, in other words. Okay, now we know what a and b are, so we can solve for c in our third equation here. This equation tells us that 6 times a, well, a is negative 1/6, minus 8 times b, well, b is 1/6, minus 12c, what we're solving for, equals negative 1. So now we just need to solve for c. So first of all, these 6's cancel, which is nice, so negative 1 minus 8 over 6, that's the same thing as 4 over 3. 4 over 3 minus 12c equals negative 1. Okay, I'm going to get everything with a denominator of 3 just to make this simplification a little bit easier. So that means that we have a negative 3 over 3 minus 4 over 3 minus 12c equals negative 3 over 3. And that's again just by writing everything that doesn't involve a c with a base of 3, which just makes the arithmetic a little bit easier. And again, you could solve this equation in any way you wanted. This is just a system of 4 equations with 4 unknowns. So as long as you get the right coefficients, then the method you use does not matter. Use whatever you're comfortable with. I'm just showing you what I would do. Okay, so negative 3 minus 4 over 3, that's going to be negative 7 over 3 minus 12c still equals that negative 3 over 3. All right, so let's add a 7/3 to both sides. So we have negative 12c equals negative 3 plus 7. So negative 3 plus 7 is just going to be 4. So this is just going to be 4/3 like that. Okay, so then we can just simply divide by a negative 12, and we're left with 4 over 3 times negative 12, which is the same thing as negative 4 over 36, like this. And we can divide both sides by 2, and we're left with negative 2 over 18, which is the same thing as negative 1 over 9. Okay, so we found c to be negative 1 over 9, and now we only have one more equation to deal with, and that's this guy up here. And I'll do that a little bit over to the left. Okay. So 2b, well, 2 times b is the same thing as 2 times 1/6 minus 4 times c. Well, we just found c, and we just said that it was negative 1 over 9 minus 12d equals 3, and d is what we're solving for here. So 2 times 1/6, that's the same thing as 1/3. I'll write that nicer, 1/3 And then so plus 4 over 9 minus 12d, 12d equals 3. Okay, so again, I'll get everything in terms of a common base, and here that seems to probably be 3. 3/9 plus 4/9 minus 12d equal 3 times 9 over 9. So 3 times 9 is just going to be 27 over 9. Okay, so 3 plus 4 is the same thing as 7, still over 9, minus 12d equals 27 over 9. Subtracting a 7/9, we have negative 12d equals negative 20 over, or just regular 20, my bad, equals 20 over 9, just like that. So now we can divide by a 12 here. So let's see, d, or a negative 12, so d equals negative 20 over 9 times 12, and now we just need to simplify d. So let's see, d then equals, well, we can simplify the 20 over 12 first if we want. This is the same thing as saying negative 1 over 9 times 20 over 12 is the same thing as 10 over 6, which is the same thing as 5/3. So 5 over 3, and that will give us a d equals negative 5 over 9 times 3, which is 27. Okay, so we solved our system of equations, and we have our coefficients, and we can finally write our non-homogeneous part of the solution. So yn of x then equals, if you remember, ax cubed plus bx squared plus cx plus d. And so we just found what all of those coefficients were. And so a was 1/6, I believe, or no, it was negative 1/6, so negative 6x cubed. And then b was the 1/6, so 1/6 x squared. And then c we found right up here to be negative 1/9. So negative 1 over 9 times x, and then we just found d to be negative 5 over 27. Okay, so now all that's left to do is to combine the two solutions we found with step 4. So remember, y of x equals yh of x plus yn of x. Now let's see, yh of x is going to be all the way up here. Let's see if I can just memorize it real quick. Okay, c1 e to the 6x plus c2 e to the negative 2x. Okay, so this is then going to be y of x equals c1 e to the 6x plus c2 e to the negative 2x, and then add on our yn of x. This is going to be this is going to be a minus, so minus 1/6 x cubed plus 1/6 x squared minus 1/9 x minus 5 over 27. Whew, and that's going to be our final answer for this ODE using the undetermined coefficients method. Here we are with our last example of the video, and so I encourage you to pause here and see if you can solve this one by yourself. Actually, we have already solved the homogeneous part of this in the first question, so this will really be just a little test if you have been understanding the undetermined coefficients part. So I'll give you some time to do that. Just pause the video, but I will go into the solution right now. So step 1, find the homogeneous solution. So the homogeneous version of this equation is such as this, which equals 0. So we write the characteristic equation, r squared plus 4r plus 3 equals 0. And so we can just factor this guy, and this will give us r plus 3 and r plus 1, which equals 0, giving us r1 equals negative 3 and r2 equals negative 1, which means that the homogeneous part of our solution, make that h a little bit more obvious, equals c1e to the negative 3x plus c2e to the negative x. And now we can move on with the undetermined coefficients part. So step 2, undetermined coefficients. Well, here g of x equals just 3x. So we know that our expected solution, what we call y non-homogeneous of x has to be a first order polynomial, but with constant unknown coefficients. So this is just going to be ax plus b, because we can't skip any orders and x to the 0 is an order. So now we just need to take derivatives of this expected solution and then plug it into the original ODE. Yn prime of x equals just a, and yn double prime of x equals 0. So that's actually going to make life a little bit easier, right? Because inevitably we need to plug this into the actual ODE, which we're going to do now. Okay, so the actual ODE, I'll write again, y double prime plus 4y prime plus 3y equals 3x. Okay, so now let's plug in these three guys right here into our ODE. Well, y double prime, luckily for us, is 0. Then we add 4 times y prime, and in this case, y prime is going to just be a. Then we add 3 times y, which is ax plus b. This equals 3x. Okay, so let's just distribute the 4 and the 3 and see if this looks a little bit nicer. 4a plus 3ax plus 3b equals 3x. Okay, so now let's just group by the power of x. There's only one x term here, that's going to be 3a. There's going to be 2 constant terms, and that's 4a plus 3b, which equals 3x, like that. Okay, so remember, this has to equal the coefficient in front of the same power on the right side. So here, this is pretty nice, 3a equals 3. So we know immediately that a equals 1. And so doing the same thing with the constant terms, well, there's no constant term on the right side. So 4a plus 3, oops, let me write that a lot better. So 4a plus 3b then must equal 0. We know what a is, so 4 plus 3b equals 0. And therefore 3b equals -4 and b equals -4 over 3. And so actually in this example, it didn't take very long to solve for those coefficients. So this method, it doesn't always take super long. And now all we need to do is write out our non-homogeneous part of the solution, and then combine that with the homogeneous part. So we guessed the form ax plus b. So we know what a is, that's just going to be 1, so ax is x, and then minus 4/3 for our constant term here. And that's just by plugging in a and the b that we found into our expected form of the solution. All right, so now we can just go ahead and combine, and this is step 4, we can combine these two solutions into our final solution. YH of x plus yn of x. So y of x then equals c1 e to the -3x plus c2 e to the -x, and then this is going to be plus x minus 4/3. All right, so that's going to do it for this final solution. Okay, so that's going to be it for the video, and let me know if you guys have any specific questions or something you want me to go over more in depth in a later video. Keep an eye out for the next video, which will be the same kind of ODE. Instead of equaling a polynomial, it will equal an exponential function, which a lot of times is actually easier. Okay, so I'll see you guys in the next one.